Alright guys, so we have a speed drill. Basically it's a variable speed type. It is 4.1 amps and it's operated at 120 volts. It's a made in USA brand, and it's roughly alright. So this is a very useful brand, and it's has been very effective, as it might not be the most popular brand, but I've been using this drill for almost 10 years, and you know, it's very fancy. It comes with a little level at the top so you can hold the drill straight. Alright, so the problem I encounter with this drill is that, you know, it just stopped work, perhaps because it wasn't being used for a while. So we're just gonna walk through over it and see what might result in such problem. Say for example, had the drill, you know, sit down or place at one particular place over a period of time, and you know, it's not being used. So there might be quite a few, you know, situations that might arise due to the drill not being used over extensive period of time. So let's look into it from a more in-depth perspective by unscrewing the whole thing apart and looking at the various components of the drill. And we're going to do a few testing on it just to make sure that, you know, we're getting the correct voltage at these points and so forth. Alright, so those are the only things that I can do to guarantee that the drill may need correction in certain area. Alright, so we need to itself is working. Alright, now we said what could possibly cause it not to work when it was working before. Alright, so it was sitting down over a period of time and it's not being in use. So I'm gonna find the problem and see if I can work on it. Alright, so we're just going to go in depth by unscrewing the thing apart, and then we can explain the whole situation with the drill. Alright, and we're going to do it carefully because we don't want to have any mistake, and then after which we may have more problem to deal with. Alright, so at this time, you know, I just want you to take a good look at it so you can see what type of drill is this. It has a little power card here. Alright, that fed to the outlet. Okay, so let's run over it again. It's a Skill brand, made in the USA. Alright, and it's a variable speed drill of 4.1 amps, and it operates at a hertz of 50 to 60, and the voltage level is 120 volts AC. Alright, so that's just about it. Okay, so let's get going. We're gonna unopen the drill, and then we're going to go in depth to see some of the things that make it up. Alright, and hopefully we can learn a thing or two by doing that, and then we may look into the problem and see what it is. Alright, so let's get started. Alright, so I'm using the screwdriver here. Right, this is just a regular screwdriver here. Right, perhaps it's a leveling one. Right, so let us use this screwdriver here. Alright, so gonna unscrew each in this section, right? I'm gonna just loosen him a little bit, right? Okay, alright, so as I said, we're gonna be careful because we don't want anything to go wrong while we unscrewing the whole thing. Okay, so just put this piece aside. That's the cover. Alright, so you can look directly in the whole piece of the drill, as you can see. Alright, so this is the gear at the top where the chuck is. Alright, so we have the gear, and we have the motor here, and the fan to this section here. So easily, as I recognize, the brush just popped out. Alright, so you have to be careful, because this is where, you know, the voltage comes in. Alright, so I don't want to interfere with this component. Alright, so what did happen was, you know, that we have to really sort the reason why, you know, the drill stopped work, due to the fact that it was sitting down over a period of time. Alright, so I'm going to look further to see some amount of corrosion or resistance between the electrical component that somewhat would have resulted in such problem from occurring. So the brush, one here, we may want to just clean up a little bit. Alright, and you know, we just want to make sure other things on the drill actually works and it does not interfere with the whole operation. Like here we have the switch. Okay, so this is a switch, and this component basically, right, this component is what controls the on and off operation and the speed. Right, and then this is a directional control, this part here. Alright, this makes sure that we can rotate the drill in the other direction in case that it might get stuck when you drill it into the wall. Alright, and then these are this is the stator coil. Alright, I don't want to pull everything apart because it makes no sense. I can already see the other parts of the electrical wires and the components. As I'm saying, I'm just going to do a few testing on it, and then after doing the testing, hopefully I got the voltage what I'm looking for and the current and so forth. Alright, so this one is going to be more likely a quick evaluation, because you know, you can't go too, as I'm saying, still I might go in depth, but I don't think more or less I need to really try to that nothing really wrong with the drill. Alright, but let's say we do all the testing on it just to make sure that we get the right voltage and so forth. Alright, so say I pick it up in the morning and I did not see anything work. Alright, and I got a little bit worried because, you know, this drill works very well and I have it for a good while. Alright, I'm just going to do some testing on it and make sure that we're getting the voltage across the stator winding and also the rotor winding. Alright, So if we get voltage to the rotor and we get voltage to the stator, then we're supposed to have a revolving field, all right, or a rotation of the shaft due to the electromagnetic interaction. All right, so let's get into that right now. All right, so first thing, we're going to test each component and see what power is going to each part of it, and if they're actually getting in the source, and if so, then we'll see what we're going to have to do next. As I said, I might have to clean up certain things, you know, like the brush and so forth, and you know, get maybe just make sure, you know, that everything is in perfect condition. Alright, so this drill basically utilizes 120 volts. So I need to know if 120 volts is actually going to the brush and 20 volts is going to the stator winding. Alright, so there must be interaction between the stator and the rotor. Alright, so we're going to test the voltage in between the stator and the rotor and see what it's going to be like. Alright, so let's do it. Alright, so I'm using a meter here. This meter is goes up to roughly 400 amps, and I said it's a salt wired brand, and it have automatic operation. Basically, it runs in between modes, where you can change for volts or hertz, ohms, continuity, temperature, etc. Alright, we also can test capacitance. So we're just going to test and see what the input power or voltage to each part of the component. So if we find the voltage going to the component, chances are we say that everything should be okay. And then from that, we might want to make sure our brushes is clean enough that the voltage can actually reach the stator or the rotor. Alright, so we're going to make sure, right, that we actually get in these value that we're looking out for. Alright, so first I'm going to test for voltage across my brush. So I can see at this point I'm not really getting any voltage across the brush. Alright, but the trick to this thing is that the brush, let me show you the voltage on my screen, it's very important. So I'm testing across the brush. So I want to show you the voltage while I'm testing. Alright. So the voltage as it is actually 0. Alright, I'm just gonna remove the second brush. Let's plug out power. Alright, so the power is already plugged out. So I might just remove the brush. Alright, so we're gonna do another test just to make sure the voltage is actually what it's supposed to be. Alright, so we're going to do a testing across each component of the brush. Alright, so we're getting 0 volts across the brush. Right? So no power is going through the brush at this time. Alright, no power. So the brush is supposed to transfer the power to the commutator. The commutator is this piece here in the back here. Alright, so that allows the current to go to the rotor. Alright, so the current transfer from brush to commutator. Alright, and then it interacts with the power in the stator winding. Alright, and the stator already has power feeding to it. Okay, so let's look at it one more time. This is a commutator, it's on the rotor, and then this is the stator winding. So there's a rotor winding and there's a stator winding. Alright, so you can't really see the rotor winding, but this rotor winding actually, is right there. I don't really want to lift it up too much, but you can see a glance of it, right? Because the power is actually active right now. I don't really want to interfere with it that while the power. But so look at it. You see the winding for the rotor. Alright, so when the power goes to the commutator, it transfers to the rotor, and then that will interact with the stator winding. Right? So that's just about it. So I got my meter hooked up in neutral, and I'm just gonna test across the power from the stator winding and see if I get the accurate power to the draw. Alright, so I'm just testing. Let's say I'm testing. I'm getting getting 0. But remember, I need to continue the power that comes through the cable, then through the switch. Remember, this is a switch, so I gotta close the switch across the circuit, and for it to continue to the brush. All right. So if we get power to the brush, chances are we'd have no problem with the rotor. All right, and then we have to test our stator as well to make sure we're also getting power to the stator. All right, because we need electromagnetic interaction between our stator winding and our rotor winding. All right, so let's go ahead and we're gonna see what it's going to be like. All right, might have to offer or create a protection in between the stator and the rotor. All right, so I mean protection when I'm testing, right, the switch here, I would say. So I'm gonna depress. Ooh, see, so right there make an error. I almost have a spark here. So you're working with this thing here now, you have to be careful. Alright, so again we have to work safe because we can't afford to make anything burn. Right there I see a problem. The insulation on the switch is actually being removed. Alright, so we have a problem right there, so we're gonna have to address. Alright, so we're going to have to work on that problem. So let's try and depress the switch one more time so we can get this out of the way. Right, so the wire at this point is exposed, so I need to find a way how to insulate it back over so that it don't deteriorate. Alright, so I might have to get some tape and wrap around it. Alright, so right now I'm gonna try and test one more time. So there's some grounding taking place right there, so let's separate it a little bit. Alright, so we just depress the power, so we gotta test, alright, against the brush. Okay, so we're not getting anything against the brush. Let's try once again. Try once again. Alright, so gotta keep testing. Sure we're getting 111 volts across it. Alright, and bring the meter close so you can get a look at it. Alright, so let's try once again. Alright, so what I did was to find a ground at the outlet, and then I'm going to take the power or the red leads and touch across each component just to make sure we're getting power. Alright, so I'm just doing that right now. So I'm going to just check. I'm just going to check the voltage coming in. Alright, so I'm getting like 78 volts. It goes to show me that I'm not getting any good ground on that side. So power is actually reaching the circuit, but not getting any good ground. Alright, so we get our low voltage because we're not really making ground properly. Alright, so let's try once again. Alright, so what we did was to make sure that we have proper grounding. So now we're going to test each component and see if we're actually getting the voltage. Alright, so you can see the voltage on the meter here. It's actually changing. We're getting 130, 110 volts. Alright, and that's from the brush. The other brush is reading 0. Apparently that's the neutral side. Alright, and this is the positive side. And then, so we try the brush, we actually see power going to the brush. Alright, so the next thing we're going to check is the stator winding to see if the correct voltage is actually reaching the stator. So I'm going to test the voltage at the point deliver to the stator. Alright, so I'm getting 111 volts, 0.7, 111 volts, 0.8. Alright, so that's a good look for us right now. So we're getting power to our stator. We're going to check for power to our rotor. Alright, so look, we're going to look at the other side of the rotor. The rotor has 2-part winding. and that is done in order to change the polarity. Alright, because we have a directional control on it, this switch here. It's a directional control switch. Alright, so if we're getting power from after the power goes from the switch to the brush, it goes to show us that everything is okay. Alright, from this component through the directional control. Alright, so the power to the stator is 111. Alright, so that show me that the power is actually going to the stator. Alright, and then I might have to check the other side of the stator, because I want to know if, you know, power is going on both sides. Alright, so it comes with a directional control. Alright, and we're able to change direction. So based upon the wiring configuration, you can change direction and so forth. So we have seen that power is going through stator and it's going to the brush. The brush is going to connect to the rotor. So no sooner than when it's connected to the rotor, it will be able to supply the power. Alright, and then you'll have the rotor spin, and then that will transfer to the gears of the drill, and then eventually rotate the chuck. Alright, so what we're going to do, we're going to correct one thing, and that is the part where the insulation breakdown. Alright, once we can address that, more likely, and we can close back the drill, and then we can connect the brush. Maybe we clean up the edges of the brush to make sure that it is actually making 100% contact, because that could be possibly one of the reasons why the motor is not going to spin, because it's been seated for a while, and then this area may build up some amount of corrosion. Alright, so I'm just going to unplug the power, and then I'm going to have to clean it up a little bit, and then wrap the tape around this breakdown insulation. Alright, so we're just going to wrap the area where the wire has broken down. Apparently a little grease has gotten onto the wire. Alright, and this is very bad. You can't bet grease. When grease get onto any rubber insulation, it will eventually break down over time. Alright, so a little grease from the drill has exposed the wire to being breakdown in the insulation. Alright, so grease has a tendency to affect conductors. Alright, so it's gonna wrap the wire so that it maintains zero contact between the wire adjacent to it. So wrapping insulation around the wire, you know, for protection purpose. Alright, so we're gonna put back the wire in place, or the switch back in place. Alright, this is just a directional switch. And then we're gonna seat the brushing back in place. I'm just gonna do one thing before I do so. Let's just clean up the brush a little bit, and then we're going to get them back in place. So commutator, I'm just gonna clean the surface of the commutator as well. This is very important, so that we don't have any insulation build up on the surface. So that must have been one of the reasons why it wasn't working, because it been seated for a while. It built up a little insulation in between the brush and so forth. And then secondly, we had the insulation problem, which would have caused the circuit to short out, right? As we tried to test the voltage, initially we exposed a little spark, all right, because there was a little short circuit at this point here. So I just addressed that by putting a little insulation around the wire that was exposed. And then I'm going to put back the variable speed switch right here. Alright, so alright, this is a safety lock. So all I have to do is get it in place. Alright. Alright, so I get a safety lock in place, and I'm going to set back the power cable in place. Okay, so now we set everything in place. Then we're gonna have to put back the cover, and then we're gonna screw back tight the whole component. Alright, so this thing is, we have to make sure everything is properly put together. Alright, and then we can take it from here. Hopefully everything is okay after this. We don't have to go any further. So that I can get another year or two out of it. Perhaps it's gonna serve me even longer. Alright, but this is the first problem I encounter with it. Alright. So that's it. There are a few more screws to get in. That should be it right now. Alright, so I'm just gonna test it and make sure it's working the way it was. plug it in and test it once again. Alright, so that's it. Okay guys, so that's how you address the problem, you know. Give us a like and please subscribe to our channel so you can continue to get video like this. Thank you.